Hello everyone. Good evening. As you all know that in chemistry, we are having a chapter Redox reactions and rate of chemical reactions. This chapter consists of two modules. The first module is about redox reactions and the second module is about the rate of chemical reactions. Today we will discuss about the law of conservation of mass and how to balance the chemical equations. So let's start our class. Look at these pictures. These pictures are showing various changes happening around us. These include both physical and chemical changes. Don't you remember the difference between these changes? Let's recall about physical and chemical changes. Physical changes are changes that alter the size, shape, or physical state of a substance. But in chemical change, a new substance is formed. Here is a table showing the mass of reactants and products when hydrogen combines with chlorine to form hydrogen chloride in two situations. Observe the table and find out the total mass of reactants and product in the above experiment. In situation 1, the total mass of reactants and product is equal to 73 gram. And in situation 2, the total mass of reactants and product is equal to 146 gram. Given another table showing the mass of reactants and the products when hydrogen combines with oxygen to form water in two situations. From this table it is clear that in situation 1, the total mass of reactants and product is equal to 18 gram. And in situation 2, the total mass of reactant and product is equal to 36 gram. Now what do you understand from this? What is the relation between the total mass of the reactants and the total mass of the product? The total mass of reactants is equal to the total mass of the product. Am I right? According to law of conservation of mass, in a chemical reaction, the mass is neither created nor destroyed. Actually, it is conserved. This law was put forward by the scientist Anton Lavoisier. If the total mass of reactant is equal to the total mass of the product, then total number of atoms of each element in the reactant side and the product side will be equal, aren't they? Let's see a chemical reaction. A piece of magnesium ribbon is burnt. What do you observe? The magnesium ribbon burns with a white bright light and it turns into a white powder. Do you know what is the name of that substance? It is magnesium oxide. We can represent this reaction as magnesium plus oxygen gives magnesium oxide. By using simples, we can rewrite as Mg plus O2 gives MgO. Which are the reactants? Magnesium and oxygen. And which is the product? Magnesium oxide. Observe this equation. Is the number of atoms of each element equal on both sides? No, right? Here, the number of oxygen atoms in the reactant side is not equal to the product side. So how will you balance this equation? As the first step, we have to draw a table showing the total number of atoms in the reactant and the product side. Let's write the number of magnesium and oxygen atom present in the reactant as well as in the product. The number of magnesium present in the reactant side is 1. and the number of atoms present in the product side is also 1. In the case of oxygen, there are 2 oxygen atoms in the reactant side, and in the product there is only 1 oxygen atom. Now see, the number of oxygen atom in the reactant side is not equal to the product side. So let's balance the oxygen atom as the third step. As there is 2 oxygen atom on the left side and 1 on the right side, we have to multiply the oxygen atom with 2 on the right side to get 2 molecules of magnesium oxide. So we will get the equation as Mg plus O2 gives 2 MgO. See, the number of oxygen atom on both sides is balanced now. But what about magnesium? It is 1 on the left and 2 on the right. So how many magnesium atoms are needed in the reactant side? Yes, multiply the magnesium on the left side with 2. Now we get 2 Mg plus O2 gives 2 MgO. This is the balanced equation. In the next video, we will see further examples of balanced chemical equations.